Welcome back to my channel. In this video I'm going to show you some questions from engineering mechanics. As you see, it's from forces on particles. So I'm going to solve this question by using cosine and sine law. Let's see the first question. Determine the magnitude of resultant force Fr equal F1 plus F2 and its direction measured in counterclockwise from positive x-axis. So they have given the force, one force, and this force is supposed to be there, because without knowing this one we can't calculate uh, resultant. Let's say this is 375. So direction, I'm going to draw this. Let's draw this one. So y-axis, x-axis, and this is F1 is given 250 lb, and the angle between it is 30 degree. And this is F2, the angle between it is 45 degree. So F2 is, let's say, 375 lb, and we have to find the resultant and the angle between the resultant. So in order to find that, we have to draw a parallelogram, then only we can use the cosine law. So I'm gonna draw a line parallel to this force 200 lb, and underline parallel to this one. So whatever the line connect these two lines is gonna be the FR. So we know this angle is 45 degree, and they have given this is 30 degree. The total angle of this should be 90 degree. So this is 30 degrees given, this is 60 degree, and we know two sides, and this is 60 plus 45, 105 degrees. So according to parallelogram, two sides should be equal to 180 degrees. So 105 is here, so therefore the rest of the angle should be 75 degree here. So I'm going to use the cosine law. So as you know, cosine law is equal to c square is equal to a square plus b square minus 2ab cos theta. 2ab cos theta, right? So c is equal to root of a square plus b square minus 2ab cos theta. Let's solve this. So let's say a is 375, no, a is 250, and b is 375. So c is our FR. Actually we can put f1 square plus f2 square minus 2 f1 f2 cos theta, whatever the way you want, you can put it like that. A square, so we are gonna put 250 square plus 375 square minus 2 times 250 times 375 cos theta. So the cos theta is cos c, cos theta, let's say cos theta. So cos theta is the angle that is opposite to the resultant force. So FR is here. As you see, the opposite force is opposite angle of the FR is 75 degree. So we have to choose that angle here, cos 75 degree. Let's calculate this one. So 250 square, which is equal to 62,500. 62,500 plus 375 square is equal to 1,40625. 1,40625, and I'm going to calculate this all together. Let's see. 2 times 250 equal to 500. 500 multiplied by 375 equal to 187,500 multiplied by cos. Oh god, I have to do this again. Let's say 2 times 250 multiplied by, I don't know what happened. 2 times 250 500 multiplied by 375 equal to 180. Let's put that one first. 187,500. 187,500. 187,500 and cos 75. Degree. So I'm gonna add this both. 6,500 plus 140,625 equal 20125. It's 203,125. 203,125 minus, let's find out the cos 75. Cos 75 is equal to what? 75 cos. Okay, this is a value, and I'm going to multiply 187,500 by this. 187,500. So the value is giving 48,52857. 48,528.57. So let's deduct this. So I'm going to bring it to 12. So 23,125 minus 48,528.57 is equal to 1,545 root of 1,54596.43. So let's find the root. Square root of 1,54596.43 is equal to square root 393.2. 393.2 lb. So this is gonna be our resultant force. So we have found the resultant force successfully. So what do you have to, but it's not over yet. And the thing is, now we have to find the angle that makes the resultant force. So in order to find the angle that makes the resultant force, I'm going to use the sine law. So to find this angle, we have to know two sides and one angle, right? So always we have to say get the angle opposite to resultant force. We have to use the resultant force and angle opposite to resultant force in order to calculate the angle that makes the resultant force. So first I'm going to use a sine law. Sine the angle opposite to resultant force, as we know already, is 75 degree over resultant force is 393.2. So if we take the, we can take the bottom out of, so if you take the bottom side of the resultant, let's take the top side. So if we take the top side, it's 60 degree. So it's going to be sine 60. Oh, we don't know the angle. We have to find the angle. So we don't know the angle. The question is find the angle that makes. So we don't know the angle. Let's make the angle that makes the resultant force. So we are not sure whether the resultant force is straight to the line, or because it could be a little bit upper according to the way we draw the diagram, right? So the way, in my way, it looks like it's direct to x-axis, but it's not really. We don't know, so we have to find it. So theta, sine theta over, and the side opposite to this angle is gonna be this line. This line is opposite to this angle. This line is parallel to this line. This is 375 degrees, so I'm going to use that one here. So sine theta is going to be equal to sine 75 over 393.2 multiplied by 375. Let's see what we get here. And theta is gonna be whatever the inverse of that. Let's find this one first. So 75 sine is gonna be 0.965. Okay, we are gonna multiply this by 375. 5 equal to 362. So yeah, I'm gonna divide this one by 393. 3.2 and 0.9212. So now what I have to do is I'll write this number. So let's just say register it for this 0.9212. 0.9212. I have to find the inverse to find the angle. Theta is going to be sine inverse 0.9212. So sine inverse 9212, we have to find that shift sine inverse 67.1 degree. 67.1 degree. So the angle, it says 67.1 degree. Let's see the question again. So determine the magnitude of the resultant force F1, F2 and its direction measured counterclockwise from the positive x-axis. So it says 67.1 degree, and the question asks counterclockwise. So we measure this one Actually, we have to deduct the 60 to 5 because 67 is too big to be 67 degree. So we have to deduct the 60 to find the exact angle. So theta is going to be 67.7 minus 60. It's going to be 7.7 degree from the counterclockwise. So that is our final answer. So we found the resultant force and the final angle. We are good to go. So let's do the second question. The second question asks, determine the magnitude of the resultant force Fr F1 plus F2 and its direction measured clockwise from uh, clockwise from the positive u axis. Let's do this. So here we go. I'm going to draw this diagram right here. Right here. So this one says like this, and bottom, and u comes through this way, and this one go this way. This is v, and this is u, and the angle between u and v is gonna be 75 degree. So this one has given 30 degree. According to the angle law, we know that opposite are equal, so 75 degree, so this side should be 75 degrees too. Therefore we can find this 145 degree. So we know these two angles, and the angle between it's given 30 degree. 30 degree, and the question asks, what is the magnitude of the resultant force? So we have to find the magnitude of the resultant force. Let's find it. So F1 is equal to 4 kilonewton, and F2 is equal to 6 kilonewton. So these are the only two forces. We can draw the parallelogram right here. Maybe it looks like the square, it's okay. So 45 plus 30 is going to be 75 degree. So according to the parallelogram rule, the total angle should be 180 degree between both sides. So this is 75 degree, we know for sure this should be 105 degree. Then it makes 180 degree, right? So we know that. So from now we are good to use the this is FR, whatever the line that connects this one, it's FR. That's what we have to find. So according to the cosine law, what it says is FR is equal whatever the side that makes that resultant force, right? So it's going to be F1 square root of F1 square plus F2 square minus 2 F1 F2 cos theta, cos theta. So F1 we already know it's 4 kilonewton. Let's say 4 square plus 6 square minus 2 times 4 times 6 cosine 105. So this is the answer. So we can find it. 4 square is equal to 4 for 16. 6 square is equal to 36 minus 2 times 4 is 8. 8 times 6 is going to be 48. 48 cos 105. So cos 105, this is what we have to find, right? So root of 36 plus 16 is equal to 52 minus 48 cosine 105. Cosine 105. Let's find it out using our calculator. So uh, let's find it out. 40. Let's find the cosine first. So what is 105 shift cos is equal negative 2 point whatever it is and multiply by 48. So it is giving us 12.42. So let's write this one down. 52 minus 12.42. So minus become plus. So I'm going to add it directly. It's going to be 64.42. 64.42. So 64.42. We have to find the root of that. 64.42 square root 8.003. So this is our final answer. 8.03 kilonewton. So if you want to like write in Newton, you can expand it by multiply by 1000. But in this case, they have given the question in kilonewton, so we can give the answer in kilonewton too. So from the next thing we have to find out is what is the u. I mean, not the angle between you and the resultant force. Let's read the question again. Determine the magnitude of the resultant force. We have found it already, and its direction measured clockwise from the positive u axis. So clockwise. So in order to do that, I'm going to take the top side and use the sine law. So according to our thing, we have find out Fr is equal to 8.03. Let's use that one. 8.03 over whatever the angle make opposite to that is sine 105. Sine 105 is opposite to the resultant force. I'm using that, and equal to Fr. Let's say the angle that makes Fr. So let's say it's theta, sine theta. That's what we have to find out. Sine theta, opposite side is going to be this line. This line is equal to 6 kilonewton. So you don't have to write kilonewton. Sine theta. Sine theta is going to be equal to 8.03 multiplied by 6 over sine 105. Let's find it out. Let's see what it is giving. 8.03 multiplied by 6 is equal to 48.18. 48.18 divided by sine 105. Divided by 105 sine 105 sine 0. Wait. Actually, we made a mistake right here. So if we write the sine bottom in one side, the other side sine should be also in the bottom, and only the sine law will work, right? We have to be careful. Okay, 6 over sine theta. So sine theta is going to be equal to 6 multiplied by sine 105 divided by 8.03. Let's find it out. So 105 sine multiplied by 6 is equal to 5.79 divided by 8.03 equal to 0.7217. 0.7217. So we have found this. We had to find the sine inverse. Theta is equal to sine inverse 0.7217, right? Let's find it out. Shift sine inverse. So it's going to be 46.2 degree. 46.2 degree. But the question is asking, what is the angle from the U? From the U. So it means clockwise from the U. So from the U mean we have to calculate the angle only from the U and this line. So it's going to be the small degree. So we have found the angle, the whole line angle that makes resultant force, but we had to find it only from the U. So in order to do that, we had to subtract U angle. Let's say U angle. We have to subtract the 45 from the 46.2. Subtract 45 degree from the 46.4. So it's going to be 1.2 degree. It's going to give us the angle between U and the resultant force. So I hope you guys, and oh, we are not done yet. We are not done. We have one more question left. 2 more questions. Okay. The next question is asking, the plate is subject to the 2 forces at A and B as shown in the diagram, and if theta is 60 degree, determine the magnitude of the resultant of these 2 forces. Its direction measured clockwise from the horizontal. Okay, let's figure it out. So I'm going to draw this diagram right here. Okay, FA is given 8 kilonewton. Kilonewton. 8P is equal to 6 kilonewton, right? FP is equal to 6 kilonewton. And the angle that makes is theta degree. And the angle is given, that's good for us. Okay, theta is given, it's 60 degree. And 60 degree, and the angle in the bottom is given as well, it's 40 degree. And this is a straight line. So according by this we can assume this one is it should be 90 degree, right? So this is 50 degree, and this one is, if it's 60, this is 30 degree. So we know all the angles and we know 2 sides. Let's draw the parallelogram right here and here and connect this one with lines. So this is equal to this is equal to this, right? And this is our FR. We have to find the FR first. So FR is equal to what? FR is equal to FA square root of FA square plus FB square minus 2 FA FB cos theta. cos theta. So we have one more job left. We have to find the angle that makes the resultant, that is opposite to resultant force. So we know this side is 50 plus 30, 80 degree. According to the parallelogram rule, the two sides makes 180 degree, right? So this is, if this side is 80, this should be probably 100% is 100, because that then only it makes 180 degree. So we know that one is 100, and we are going to find the resultant force Fa square. So Fa is going to be 8 square plus Fb square 6 square minus 2 times 8 times 6 cosine theta. Cosine theta is going to be cos the angle opposite to the resultant force, 100 degree. So 8 square is going to be 64. 64 plus 36 minus 2 times is this 16. 16 times 6 is equal to 86. So 2 times 6, 8 is 16. 16 times 6 is going to be 96. 96. 96 cos 100 degree. So root of 100 minus 96 cos 100. So let's find it out directly and put it here. 96 cos 100. So whatever, let's grab our calculator right here. Where is our calculator going? I'm not sure. Okay, here we go. Hundred shoot cos. So 100 cos is some negative number. I multiply by 96. So it's going to be 16.67. So if it's negative 16.67, so it's going to be negative, negative, positive. So we can directly put it as 116.67. So let's find the square root for that. 116.67 square root is going to be equal to 10.8. This is our final answer. 10.8 kilonewton is the resultant force. We are not done yet. We have to find the angle that makes the resultant force. So to find that angle, we have to use the sine law. So according to the sine law, first we have to definitely use the resultant force and the angle opposite to the resultant force, because that will be very helpful. Sine 100 over 10.8 equal to, so we have to find the angle. Let's say the angle is theta over whatever the thing is opposite to that. So if we want to find with this one, we have to use sine 50. Let's like this down. Let's choose the downside. So what the angle of the side opposite to it is 8 kilonewton. This line is parallel to this one, 8 kilonewton. So we have to use that 8 here. So sine theta sine theta is going to be sine 100 multiplied by 8 over 10.8. Let's find it out. So let's grab our calculator. 100 sine multiplied by 8 divided by 10.8 equal to 0.7295. 0.7295. 0.7295. 7295. So we have to find the inverse to find the angle. Theta is going to be sine inverse 0.7295. So sine inverse 0.7295 sine inverse So it's 46.8 degree. 46.8 degree. 46.8 degree. But let's see where we have to read the question carefully again. So if the plate is subject to the two forces A and B as shown in the 60 degree and resultant force, and two forces clockwise from the horizon, So we have to be careful right here. So if they say from the horizontal mean uh, from the horizontal mean we have to deduct 50 because we measure the whole angle right here, the whole angle 50 and whatever the angle is. So clockwise from the horizontal mean we have to find the angle that only make this resultant and the horizontal line. So in order to do that we have to deduct the 50 degree. If we deduct the 50 degree, let's see what we get. Deduction 46.8 minus 50. So it's gonna be negative 3.2. Negative 3.2. So what does that mean is the angle is gonna be 3.2 degree. 2 degree we took this side, so it's gonna be negative 3.2 degree ups. Let's see. If we take the angle and that angle is making 46.8 with the radius, and if we deduct, so it's 3.2 degree downward from the x-axis. So that's going to be our angle. So that's all about it, and let's move to the next question. The next question asks, determine the angle of theta for connecting member A to the plate so that the resultant force of FA and FB is directed horizontally to the right, and also what is the magnitude of resultant force? Wow, that's great. That's a great question. But in this case, they say we have to find the theta, so we don't know the theta, right? We have to find the theta, and theta is here, right here, and that's the question. We have to find the theta. Fa, as we know already, it's where it is. So Fa is 8 kilonewton. And LV is 6 kilonewton. And the angle that makes the P is gonna be 60 degree. Angle that we're gonna make the 40 degree. Sorry about it. 40 degree. And we don't know this angle and this one. Let's find it out. If it's theta, it should be 90 minus theta. And this one should be, this one is making 90 degrees, so we know this one is 50 degree, and that's all about it. Okay, so from this one what we can find out, 90 minus theta is 50 degree. So we can use sine law to find this angle 90 minus theta. Sine 90 minus theta over the angle, the line opposite to this angle, force opposite to this angle is gonna be 6 kilonewton. This line is parallel to this line, so 6 kilonewton is equal to sine 50. So if we take this is tan 90 minus theta, right? So sine, we take this triangle, sine 50 over 8, sine 50 over 8. So we know this both, and now it's easy to find the sine 90 minus theta. Sine 90 minus theta is gonna be equal to sine 50 multiplied by 6 over 8. So sine 50, let's find sine 50 here. 50, 50 sine 50 sine multiplied by 6 equal to 4.6 and divided by 8. It's going to be equal to 0.5745. 0.5745. So in order to find the 90 minus theta, it's going to be sine inverse this number. 90 minus theta is going to be equal to sine inverse 0.5745. Mm, 0.5745. Let's say this is it, sine inverse. So it's the angle is 35.06 degree. 35.06 degree. So we found this 90 minus theta, and theta is now it can be easily found. How we can find it? We are going to subtract this number from 90 to get the theta. So theta is going to be what? 90 minus 35.06, which is equal to 90 minus 35.06 is equal to 54.94 degree. So we found the theta. Let's read the question carefully again. Determine the angle of theta connecting member of A to the plate so that resultant force of FA horizontal to right. Also, what is the magnitude of the resultant force? So we have to find the resultant force too. So now with this information, I can use this angle to find the resultant force. So instead of 90 minus theta, now I'm going to put this new angle. .06 degree. So we know the 90 minus theta, and theta we don't need it, and this one is 85.06 altogether. According to the parallelogram law, we know that the total angle of two sides should be equal to 180 degree. So here we know that this angle is 85.06 degree. Therefore, what we have to do is we have to deduct this number from 180 degree. 180 minus 85.06. 180 minus 85.06 is equal to what? 94.94. 94.94. That's gonna be the angle opposite to the resultant force. So now we can use our cosine law. So FR is going to be equal to what? FA square root of FA square plus FB square minus 2 fa fb cos theta, right? So in this case, what I'm going to do, instead of fa, I'm going to plug these numbers. So fa is, we know, 8 square, plus fb is going to be 6 square, minus 2 times 8 multiplied by 6. Cos theta we found it, like cos theta we found it already, cos 94.94. So we know 8 square is equal to 64, 6 square is equal to 36, both are equal to 100, and 2 times 8 is going to be 16, 60 times 6 is going to be 96, 96 cos 94.94. So let's calculate this one. 96. Let's find the cos first, so it will make our life easier. 94.94 shift cos multiplied by 96 is equal to negative 8.26. Let's say it's 100 minus 8.23, right? Minus 8.23. So from this information, we know the whole thing is going to be square root of 108.23. 108.23. So now I'm going to find the square root of this. 108.23 square root is going to be 10.4 kilonewton. That is our final answer. We have done it all. I hope you guys enjoy this video. Thank you for watching.